Hello everyone. In this video, we are going to talk about solving linear systems. And you are familiar with these linear systems. Actually, you studied this last year. But what you studied last year was linear systems with two variables, and you only had two equations. And in this topic, you'll have three variables, three different equations, three unknowns, three equations. So the methods that you used last year were elimination, substitution, and graphing, and this year we're going to just do elimination method. The first thing we need to do to solve the system will be reducing 3 by 3 system to 2 by 2 system. And you know how to solve 2 by 2 system. We just have one more extra step. So what is this extra step? You are going to use pairs first to eliminate one of the variables. Your first goal is eliminate one of the variables. To do so, you are going to pick pairs. You are going to group equations. Let's say this is the first equation, this is the second, this is the third. You group first and second and third, because you need two equations to solve a system. So you are going to generate two new equations. By eliminating one of the variables, you are going to get two new equations, and by solving these two new equations, you are going to get one unknown. By plugging it back into one of the equations, one of the 2 by 2 equations, you will get the other unknown. By plugging them both back into one of the original equation, you will get the last unknown. It will make sense as we solve questions. Let me explain one question. Okay, first we are going to eliminate one of the variables. So which variable is reasonable to eliminate? First you think about this. Is it easier to eliminate x or y or z? Look carefully in the equations. Do you see any opposite coefficients? So I see opposite coefficients here, 2y and negative 2y. So it seems to me that eliminating y is the most reasonable choice. So I'm going to eliminate y first. So to do so, I need pairs. I'm going to pair two equations. First and second equations looks easier to eliminate. So I'm going to use first and second equations first. So you can label them like equation 1, equation 2, equation 3. And let's start solving. Equation 1, you add equation 1 and equation 2. Equation 1 is x plus 2y minus 3z equals negative 2. Equation 2 is 2x minus 2y plus z equals 7, and add them up. When you add them up, 2y minus 2y will cancel each other. Add the others. X to x makes 3x. Negative 3z plus z makes negative 2z equals negative 2 plus 7 makes 5. So we generated another equation. Let's name this equation. Let's call this equation as equation 4. I need another pair to solve for x or z, right? With only one variable with only one equation with two variables, I cannot find answer. I need another equation. So I need to generate another equation by using another pair. I already used 1 and 2. 3 is left. So I'm going to use 3 with one of the other variables, one of the other equations. So you are going to add 3 to one of the other equations. It doesn't matter what equation to pick, but try to pick the easy one for you to eliminate. So you are eliminating y. In 3 you have y. In the first equation you have 2y, second negative 2y. So the second and third, the sign of coefficients are opposites. So it's easier to eliminate if you use 3 with 2. But whatever you are using, you'll get the same answer. Equation 3, x plus y plus 2z equals negative 4. Equation 2, 2x minus 2y plus z equals 7. So add them up. When you add them up, you cannot eliminate twice unless you multiply the first equation by 2. You need opposite coefficients to eliminate y's, but in the first one you have only 1y, in the second one you have negative 2y. You should have 2y here. So multiply this part by 2. So multiplying by 2 will make your new equation 2x plus 2y plus 2 times 2, 4z equals negative 4 times 2, negative 8. The other equation remains same, 2x minus 2y plus z equals 7. And now add side by side, negative 2y. 2y will drop out 2x, 2x, 4x, 4z, z, 5z equals negative 8 plus 7, negative 1. So let's name this equation as equation 5. Okay, we used 1 and 2, we generated equation 4. We used equation 3 and 2, generated equation 5. Now let's use them together. Equation 4 and 5. We reduced our 3 by 3 system to 2 by 2 system. Until this step, everything was new. But after this step, you know what to do. You solve them and eliminate one more variable. 3x minus 2z is 5. Equation 4. Equation 5. 4x plus 5z equals negative 1. So now add them side by side. You decide which variable to eliminate first. As you can see, the signs are opposite here for z. So z is a reasonable variable to eliminate. But their coefficients are not same. You have to make them same by multiplying them by each other. Multiply the first one by 5. The second one by 2. To make them opposite, to make coefficients opposite. 3 by 5, 15x minus 5 by 2, 10x equals 5 by 5, 25. The other one, 2 by 4, 8x plus 2 by 5, 10z. Excuse me, there was z here. And 2 by negative 1, negative 2. So these will drop out. You will have 15 plus 8, 23x equals 25 minus 2, 23. By dividing both sides by 23, you get your x as 1. Finally, we got something. So now you need other variables as well. By substituting one back into one of the 2 by 2 equations, you will find x. You will find z. So pick one of them. Which one is easier here? They're in the same difficulty. So let's try the first one. 3 multiplied by x, which is 1, minus 2z equals 5. 3 by 1, 3. Bring it to the other side. Negative 2z equals 5 minus 3, 2. Divide both sides by negative 2. Z becomes negative 1. You got the second variable as well. And finally, the last one. To find the last one, you are going to plug in 1 and -1 for x and z into the one of the original equations. You pick one of the original equations and substitute them back, and you will find the other unknown. Let me use the third one. I don't have coefficients for x and y. It seems easier for me. X, which is 1, plus y, which is unknown, plus 2 times z, which is -1, equals -4. 2 times -1, -2, plus 1, -1. Move -1 to the other side. -4 plus 1, -3. So y becomes -3. So we solved our equation. We get an ordered triple. So let's write this as a point. Our solution is 1 comma -3 comma -1. We have an ordered triple as a solution. So these are the ways. Let me wrap it up. First of all, we pair equations to eliminate one of the variables. We paired 1 and 2 and 2 and 3. We eliminated y because y was easier to eliminate. We reduced our 3 by 3 system down to 2 by 2 system. And we solved this 2 by 2 system